Ray optics, equivalent lenses, equivalent focal length and power of two thin lenses in contact. Here, L1 and L2 are two thin lenses. They are in contact. This is object distance C1O, which is U, and image due to first lens is formed at I dash. So image distance is V1, but because of second lens, final image is formed at I. So this distance is taken as V. Now let's write the equations for lenses. So for first lens, 1 upon f1 equal to 1 upon v1 minus 1 upon u, equation number 1. And for second lens, we write 1 upon f2 equal to 1 upon v, because final image is formed at I, which is V, and for second lens, I dash acts as virtual object. So object distance will be V1. So equation number 2. Now adding 1 and 2, we will get 1 upon F1 plus 1 upon F2 equal to 1 upon V minus 1 upon U, because 1 upon V1, 1 upon V1 will cancel out. And we know that 1 upon V minus 1 upon U equal to 1 upon F. So we can say combined focal length F will be 1 upon F equal to 1 upon F1 plus 1 upon F2. Combined power, since 1 upon F is P, so P equal to P1 plus P2. Now let's consider next case. Two thin lenses separated by small distance. Here these are two thin lenses L1 and L2. They are separated by distance D. Now here separate diagrams are shown to see the deviation produced by two lenses. So L1 produces deviation delta 1 and L2 produces deviation delta 2. Although here manifestly things are not shown. So for clarity, these two diagrams are given. Now let's consider deviation produced by first lens. This is a ray. When it reaches here, it follows this path and image is formed at F in absence of second lens. So delta 1 is taken as tan delta 1 for smaller angle equal to perpendicular for this triangle AC1F. Perpendicular is H1 and its focal length is C1F, which is F1. Suppose this is equation number 1. Now deviation produced by second lens. So C2. So C2F2 is taken as small f2. So delta 2 will be equal to tan delta 2 is equal to H2. This distance is taken as H2, or here you can consider this is H2 and H2 divided by F2. Clearly, net deviation produced delta will be sum of the deviations produced by the two lenses. So delta equal to delta 1 plus delta 2. And delta will be equal to, this is delta. So delta will be equal to this height. So DC is same as H1, and we are considering the final focal length or resulting focal length as F dash, because final image is formed here. So we can say that DC divided by CF dash. So we write it as delta H1 divided by, suppose CF dash is equivalent to F combined focal length, and delta 1 is given as H1 upon F1 plus delta 2 is given as H2 upon F2. In triangle AC1F and BC2F, we see that they are similar, so their sides will be proportional. So we can say H1 upon F1 equal to H2 upon this distance C2F, which is from here to here, this is F1, and this distance is D. So we can say that it is F1 minus D. From here, we can get the value of H2. So H2 will be H1 times F1 minus D divided by F1. So we put this value here, H1 upon F equal to H1 upon F1 plus H1 times F1 minus D divided by F1 times F2. Now we simplify it. So on simplification, we get H1 will cancel out from each term. So we will get 1 upon F equal to 1 upon F1 plus here F1 divided by F1 F2 minus D divided by F1 F2. So from here F1 will cancel out. So we will get 1 upon F equals 1 upon F1 plus 1 upon F2 minus D times F1 F2. So this is expression for combined focal length, where this is not D1, this is D. D is separation between the two lenses. Now suppose we want to write power. So combined power P equal to P1 plus P2 minus D times P1. Thank you for watching.